All right, IBAISL2. Today we're going to talk about a couple different topics, mostly just expected values and variance. We're still looking at them through the lens of binomial distributions. So just a reminder, this is a binomial distribution. The way we've been finding certain parts of those binomial distributions are using binom PDF and binom CDF. Remember, PDF is for exact, exact certain parts of the distribution, and then CDF is for cumulative parts, where you're adding certain things together. The two things we're going to introduce today is how to find an expected value. So this is the expected value. And that's actually pretty straightforward. You just take n is the number of trials, and p is the probability of the event happening. So if you want to find the expected value, you just multiply n and p together. It's real quick, two numbers multiplied. The other thing we're going to do is variance. So variance is kind of a three-part computation where you take the number of trials, you multiply it with the probability of what you're looking for, and then multiply it times 1 minus the probability. So it's almost like the complement of the probability that you're looking for. Just a reminder that variance measures the spread. It has a lot to do with standard deviation. So low variances would have sort of a tighter distribution. So a low variance would mean sort of like, the distribution is very clustered. So this is low variance. And a higher variance would mean that it is much more spread out. Now, something I keep struggling with this unit is like even picturing what this means. I'm like, that's a weird notation. What are we even talking about when you write B and P? I wanted to show you guys an example of, like, let's say you were flipping a coin 5 times. If you flip a coin 5 times, like, the probability that you get a heads or a tails is 1/2. So I went ahead and put a 1/2 right here. And then the number of trials would be 5 because we're doing it 5 times. But this is a binomial distribution. So I came up with a graph to kind of show you what this looks like, where probability is the y-axis, and then this, I didn't label it, but the x-axis is exact number of heads or tails. It doesn't even really matter because their probability is totally the same. So if you run binom PDF 1/2 in your calculator, it's like a 0.05 probability or something like that. It's very, very small. And that's the probability of getting no heads when you flip a coin 5 times. If you put in binom PDF 5, 1/2, 1, it jumps up to like a 0.105 or something like that. So it's like the probability of getting exactly 1 head is higher than the probability of getting 0 heads. That's because you can have that 1 head show up in 5 different spots. There's 5 different ways for it to happen. Then if you do the probability of getting exactly 2 heads, the probability jumps up to like 0.3125 or something like that. Punching it into binom PDF, once again, just using that calculator. Then the probability of getting 3 heads is the same as that. And then we kind of get this symmetrical thing happening where the probability of 4 heads is the same as probability of 1 head, and the probability of 5 is the same as probability of getting 0. Which makes sense because if, this probability is 1/2, then the complement of that happening is also 1/2. So you get this nice even distribution here. So this is a binomial distribution. Now, these distributions aren't always symmetrical like this, where there's a line down the middle. Like if this number changes, that can shift it left and right. But I feel like it was sort of abstract, always writing this like, what even is this? It's like, the probability with a certain number of trials, and then you can find certain parts of the distribution using binom PDF or binom CDF if you're looking for like a less than or greater than situation. One example we're going to do today, and it's going to go pretty quick. 2 machines and a light bulb factory are being inspected because quality control raised concerns. Managers have found the probability the first machine produces a defective light bulb is 0.3. So the first machine, which I think they're calling X, makes a defective light bulb 0.3 or 30% of the time. Probability of the second machine that makes a defective light bulb is 0.02. So second machine slightly better. They take a sample of 6 light bulbs from the first machine and 5 from the second. So notice when they set up their binomial distributions, the first one has a sample size of 6, the second one has a sample size of 5. Compare and contrast the central tendency and spread these binomially distributed Compare and contrast the central tendency and spread. So we're going to look at the central tendency, which is the expected value, and the spread, which is the variance. So we're going to use the expected and the variance formulas. Okay. Let's look at X first. The expected value of X is 6 times 0.3. So you just take the trials and the probability and multiply them together. So we get 1.8. The expected value, sorry, fix that. The expected value of Y, not X, jolly, come on. Is 5 times 0.2, which turns out to be 1. So these are the measures of central tendency. They're kind of like an average. Yeah, so machine X has almost twice the expected value. So on average, remember expected value is basically an average, machine X is producing light bulbs that fail almost twice the time. Now, that was us looking at the central tendency, which is just code for the expected value. It's like the average. Now we're going to look at the spread. So the formula for variance is you take n times p and then multiply it times 1 minus p. So the variance, which we'll just say var x is equal to 6 times 0.3 times 1 minus 0.3. Or 0.7, and this equals 1.26. The variance on y is going to be 5 times 0.2 times 1 minus 0.2, and this equals 0.8. So what this tells us is that machine A has a higher variance. So this means, sorry, not machine A, machine X So machine X has a higher spread to its data in the number of defective light bulbs. So the number of defective light bulbs is going to be more clustered towards the center with this machine. So let's say this is more clustered. And this guy is more spread out. Okay, you guys, that was today's lesson. Basically just expected values, the central tendency, the average, and the variance, which is like standard deviation and helps you measure the spread of the distribution. Please ask me questions during class about your homework. Good luck.